Alright, let's talk about capacitors. So, if you've seen one of these, this right here is a capacitor, and they come in a lot of different shapes, not just this. So here's a couple of them right there that you'll recognize. And a capacitor is basically a storage tank for electrons. It is kind of like a rechargeable battery. It doesn't generate its own voltage, it just stores it. So capacitors are rated in what's called farad. And the symbol for farad is F. So a capacitor is made up of two conductive sheets, so two pieces of metal pretty much, that sandwich a insulator in the middle. And that insulator is called a dielectric. The difference between capacitors is made up of the size of the conductive sheets and how close they are together and the type of dielectric. So there's many different things that contribute to what the capacitor's capacitance is. Let's look at what this capacitor is. So this one is a 100 microfarad and it's a 50 volt capacitor. So the capacitor will be rated in what voltage maximum it can handle, and then the farad. And also there's two different types of capacitors. There is polarized that have a positive and negative side, and then there's unpolarized which do not have a positive and negative. They can be charged in either direction. So the ones that have a positive and negative, you do not want to charge backwards because it will explode. So here's two different types. This one is called the electrolytic capacitor. This one is polarized, has a positive and negative. And the way you tell which side is a negative is it will have a strip, or it will have a strip that is made up of arrows, and the arrows will always point to the negative side, and the strip will also only be on the negative side. Another way you can tell the negative side is on a brand new one, the shorter lead will be the negative. So another thing you need to know about capacitors, mainly electrolytic, is there's two different types that they make. This one is called an axial, where the leads come out both ends of the cylinder, and this one is called a radial, where both leads come out one side of the cylinder. Alright, so let's go ahead and test out a capacitor. This one is a 50 volt 100 microfarad. So this would look like 50 volt 100 microfarad, and what the symbol is for a capacitor in a schematic would be this, and the positive side is the solid line, and then the curved side is the negative. Another one you'll see is just two solid lines, and then they'll mark which side is a positive. The non-polarized ones would just look like this. So it can go either way, negative or positive can be on either side. We're going to put voltage to a capacitor and charge one up and just show you that it holds the charge. Alright, I'm putting my positive lead on the long one, the one that does not have the stripe marking. And then this one's my negative. I'll go ahead and put my meter on it to prove I have it set up correctly. Alright, there we go. So it's showing 14.3. I'm going to disconnect it from the circuit. And there you can see it's holding a charge, but it is dropping. Capacitors do have a very small internal resistance, and it gets the resistance gets lower over age. They just lose their ability to hold a charge over time, especially the electrolytics. The electrolytics I see go bad more than any capacitor. They will start to bulge on the top. They'll start to leak out their dielectric. It's basically an oil. It's a film of paper in there soaked in a dielectric oil. So it's holding a charge, it's just starting to slowly drop. And then if you put the two leads together, there it's lost all of its charge. Put the leads back on. Got charge back again. Take it off. It just slowly drops. The amount of power that a capacitor could supply would be less than a battery. So let's see how a capacitor would react in a circuit. So a capacitor is let's say we got plus 14 volts DC going into this capacitor and straight to ground. So we're going to charge this capacitor up to 14 volts. So a capacitor, it's going to take time to charge. And when it's charging, it's going to draw current to start charging that capacitor. So as it's charging, your amps. Alright, so it'll draw high current at the beginning and then drop off as the capacitor starts to get fully charged. And then the voltage, as it starts to charge up the voltage will start at 0, and then it will climb to what the supply voltage is. So initially the current is high as it starts to charge, and then it drops off and the voltage starts to climb. So a capacitor acts like an open to DC voltage when it is fully charged. It initially acts like a short until it gets itself charged up, and then it opens up. So it draws current initially when it's charging, but once it's charged, it acts like an open to a DC circuit. So I'll just show you real quick something else about a capacitor. If you got a resistance in series with the capacitor, that will determine the amount of time it takes for this capacitor to reach the supply voltage. So we got our 100 microfarad 50 volt capacitor. So that capacitor can handle a 50 volts maximum, but we're only going to supply 14 volts to it. Let's say we got a 1000 ohm resistor, and the amount of time it will take for that capacitor to charge up to the supply voltage is calculated by taking the ohms times the farad. So you take 1000 times 100 microfarad is 0.0001 farad. So 1000 times 0.0001 equals, it will take 0.1 seconds to charge. Alright, So here's several different types of capacitors you'll see, and this one just tells you exactly what the microfarad is. This one's 4 microfarad, 250 volts AC. So this one is a non-polarized capacitor. Here's another non-polarized, and this one's 1 microfarad, 250 volts AC. This one is polarized. It's an electrolytic 220 microfarad 200 volt capacitor, and this marking shows you the negatives on this side. This is a non-polarized capacitor. This one's non-polarized. Here's another electrolytic that is polarized. This is a ceramic capacitor. It's non-polarized. Here's another one that's an electrolytic that is polarized. So electrolytic capacitors are the ones that I see go bad the most. You'll see them bulge on the top, and sometimes they'll just bulge up a little bit, and other times they'll blow the top completely off and leak out some fluid. Some other failures I've seen are the ceramic capacitors, where they either get stress from the leads being bent, or just heat stress causes them to crack internally, and the two conductive plates touch each other, and then the capacitor shorts out and either blows open or just stays a short. So those I see short out. Electrolytics I see change capacitance or completely just go bad. This ceramic capacitor right here just has a 101K, and the ceramic capacitors are rated in picofarad. So the 101K would calculate out to, so it's in picofarad, so this first number would be exactly what it is, second number would be exactly what it is, so it would be 1, 0, and this would be the multiplier. So this is telling you how many zeros are after the first two. So it's 1, 0, and then 1 more 0. So it's a 100 picofarad. So the K comes out to a tolerance of plus or minus 10%. You can look up the full chart online. Here's a power supply, and you might be able to point out what the capacitors are, but here's a couple electrolytics. These little blue things are capacitors. This is a capacitor. These are some surface mount capacitors. You have these big yellow rectangle capacitors right here, these three, and you can see the dark stripe on one side of the capacitor, and contrary to these big cylinder type capacitors, these surface mount rectangle ones, the dark stripe actually marks the positive side. And the way I know that is because the board actually has a plus sign there showing that that's the positive side, and right there is the stripe, and there's a positive sign. And right here you see these 4 surface mount capacitors here, and they're just a tan color with no markings, so those are surface mount ceramic capacitors right there. So here you have some capacitors that are actually black. This is typically what a diode would look like, but these are actually capacitors. And the way I know they are capacitors is because of the identifier that they have on the board. So this one says C45, and a capacitor will always start with a C for the identifier on the board. So this is C45, C32, C44. So these 3 right here are capacitors, and the marking here on this surface mount capacitor is for the plus side, the positive side, and right there you can see a plus sign. So I know for sure that this marking is the plus side, and because it says C in front of the identifier, it's a capacitor. And right there you got one of those tan ceramic surface mount capacitors, and its marking starts with C also, so I know it's a capacitor. Here you got several different type of capacitors. These are, you got your ceramic capacitor right there and there. This is another type of capacitor, these green rectangle ones that are sticking up. And then you got a little tiny electrolytic capacitor right there. So the different colors and shapes of the capacitors also tell you what kind of type of capacitor it is with the dielectric, and you can go online and look up what all the different shapes mean and different colors.